All right, today we're going to pull back the curtain on a tool that honestly lets you see the invisible. It's the key to figuring out why a phone is dead when, on the outside, it looks perfectly fine. We are, of course, talking about the multimeter.
You know the feeling, right? Your phone just gives up. It won't turn on. And you look it over, and there's nothing. Not a single crack, no signs of water damage. It's maddening. So what do? What's the next step when the problem is nowhere to be seen?
Well, that's the thing. The problem is invisible. In modern electronics, the most serious faults, we're talking a tiny break in a connection, a completely fried component, a dead circuit, they're all happening on a level we just can't see with our own eyes. You can't just stare at a circuit board and spot where the electricity decided to stop flowing.
So this is really the heart of the challenge for any technician. How do you diagnose something you can't see? To fix the problem, you've got to find it first. And for that, you need a very special set of eyes. You need a tool that can, in a way, listen to the electricity itself. And that's exactly where the multimeter comes in. Honestly, the best way to think about it is like a doctor's stethoscope, but for electronics.
And that analogy is just perfect. Think about it. A doctor doesn't just put a stethoscope on your chest and have a little voice say, "You have the flu." No way. They listen for signals, the rhythm, the sounds, and they use their expertise to interpret those signals. A multimeter is the exact same idea. It gives a technician the raw signals, the data they need to diagnose the electronic sickness.
So, what signals is it actually reading? Well, a multimeter measures a few really fundamental properties of electricity. Let's break down the most important ones, especially for something like phone repair.
Okay, let's look at the core functions. First up, you've got DC voltage. That's what you use to check if the phone's battery actually has any juice. Super basic, but super important. Then there's resistance, which we measure in ohms. This is huge for finding breaks or roadblocks in a circuit. We can also measure DC amperage, which tells us how much current is actually flowing through a path. Now that last one, AC voltage, we don't really use that on the phone itself. That's for checking the wall outlet that your charger plugs into.
Now, multimeters come in two main flavors. You've got the classic, old-school analog meter with a physical needle that swings across a scale. It's actually really good for seeing values that are changing or fluctuating in real time. Then you have the modern digital meter, which just gives you a nice, clean number on a screen. It's way better for getting an exact, precise measurement. And for checking a simple connection, what we call continuity, a digital meter gives you this really satisfying beep, while an analog one shows you with a quick flick of its needle.
Okay, so theory's great and all, but how does this actually help us find what's wrong with the phone? Let's walk through a couple of real-world, practical tests to see this thing in action.
Okay, so let's say your phone has no sound. The first question is the speaker itself broken? This is a super simple test. You just set your meter to the continuity or buzzer mode, touch the two little probes to the speaker's metal terminals, and then you listen. If you hear a beep, that means the speaker's internal coil is intact. It's fine. But if you get silence, well, boom, you just found your problem, a dead speaker.
But what if it's not that simple? What if you do the test, you hear that beep, and you now know for a fact that the speaker itself is perfectly okay? This is where the real detective work begins. And this is the question that separates just swapping parts from doing a real repair. The speaker works, but the phone is silent. What does that tell you? It means the problem isn't the speaker, it's the path the signal is supposed to take to get to the speaker. We've found the symptom, but now we gotta hunt down the root cause.
So using that exact same continuity mode, a technician can start tracing the electronic pathway on the circuit board. They can follow it from the little pads where the speaker connects, all the way back toward the audio chip that actually creates the sound. And at some point, the beeping will stop. The multimeter will show them exactly where that connection is broken, some tiny, invisible crack that's the real source of the problem.
And this same idea works for all kinds of other problems. Here's another really clever trick, especially if you have one of those analog meters. The internal batteries in the meter actually output a small voltage. So, if you set it to resistance and carefully touch the probes to the right pins on an LCD connector, you can actually make the screen's little backlight LEDs glow faintly. It's pretty cool. If they light up, you know the backlight works. If they don't, you know the LEDs themselves are burned out.
So you see, we keep coming back to this central idea. The multimeter isn't just a gadget for measuring electricity. It's a tool for making the hidden world of circuits visible to us.
It's true power. The real magic of this thing is that it lets you diagnose what you absolutely cannot see. A dead speaker, a broken path on a logic board, these are problems that are literally impossible to find just by looking.
The multimeter translates that silent, invisible world of electrons into a signal we can finally understand, a number, the swing of a needle, or a simple beep. It lets us see the unseen.
And that really leaves us with a final thought, doesn't it? We've seen how this one tool can reveal a whole hidden world inside our phones. It kind of makes you wonder, what other invisible problems are all around us, just waiting for the right tool, the right lens, to bring them into focus?